Morning, students. Happy Monday. I hope you all had a wonderful weekend. I can't wait to hear about it tomorrow. Today, we are going to focus on 3.2 Intro to Function Rule. So make sure you have your Go Formative, pull it up so you can fill it out alongside me. Okay, so the warm-up today is, it says rewrite each expression as a unit rate. So unit means one. So the first one is 24 shipments every 6 minutes. Okay, so how many shipments are you going to have in 1 minute? And number two is 360 students per 9 classes. So how many students are in one class? Okay, so go ahead, pause for a second and try to figure that out yourself. Okay, hopefully you're able to work on that. So if I have 24 shipments every 6 minutes, you want to divide those. So 24 divided by 6, that would be 4. Okay, so we have 4 shipments every minute. Okay, then 360 students per 9 classes. If you divide that, that gives you 40 students per class. Okay, so it's all about dividing that so you can get 1. Right. The next thing, here's just a little video for you guys to watch. Today we're talking about function notation. This is how I always remember function notation. If you've ever seen the Sneetches movie, it might be familiar to you. So you can go ahead and watch that yourself. Okay, a function is a correspondence that assigns every element of the domain, so remember our domain is our x values, to exactly one element in our range, which is our y values. Okay, so that's kind of why I think of the Sneetches, because your domain is your input, so you're inputting a Sneetch, and then you put it through this function that spits it out as its range or its output. Okay, so you're doing something to the x, putting it through this machine, and it spits out as your y value. Okay, so that's kind of what I think of a function. I think of it as that machine that does something to those Sneetches. Okay, and your input's your domain and your output's your range. Okay, and your function is usually an equation. A relation is any set of order pairs. So you can make up any random coordinate pairs, and that's just a relationship, meaning that I have an x and a y. A relation can be represented in different ways. A list of order pairs, so you see here, all of those are listed out. You can represent it as an x and y table. You could represent it as a coordinate grid. So they went ahead and graphed all of these points. And then you can also represent it as a mapping. Okay, so a mapping is you put all of the x values, your domain, in the first bubble. It's kind of like kind of looks like a Venn diagram, but not really. And then you map them or you point them to their y values in another bubble. Okay, so these are our 4 different representations that we can have. Next one, it says the set of first coordinates of the order pair is called your domain or your x values or your inputs. There's a lot of different words for it. Those all mean the same thing, right? And then our output or our range is also your y values. Okay, so those are our 3 different names for both your input and your output, or your x's and your y's. The most common ones, obviously, we're going to use our domain and range, so make sure that you have those in your head correctly. How I always remember, if you put domain and range in alphabetical order, and you put x and y in alphabetical order, they line up. Just a little trick if you're ever like, oh, I can't remember. That's another way to think about it. Brackets, so often we use brackets when we're listing out the domain and range. Okay, so it just means that's a set of numbers that are in our domain and range. We can also do that for our points. So those are different ways that's just a way to list numbers or list points. We can represent it in a table, as we saw before, and also that mapping version. A function is a relationship where each x coordinate is paired with only one y coordinate. So that's like the big message today, guys, is each x value can only have one y value. And what that means is we can't repeat an x value because they have to only have one y value. So whenever you're trying to determine if something's a function, you want to make sure there's only one x value for each y value. And how we determine that in a graph is make sure that each x value only has one y value. Okay, so let's go ahead and look at this one. So remember, you're looking, are your x values repeated? Okay, and we can see right here that I have -3 twice and they have 2 y values. Okay, that is not a function. It is only a relation. In the graph, we can look here at our x values, and we use what's called the vertical line test, making sure that if I draw a vertical line, there's only one point that it hits. And if we look at -3 again, we can see at that vertical line, it has 2 points, so it is not a function. We look over here at graph 2, we can double check all of our x values, make sure there's only one for each, and there is, so it is a function and a relation. Okay, and then if we do our vertical line test, we can see here there is only one point on each vertical line. Okay, so let's go ahead and do some practice problems. Number 3 says use the rule 2x plus 3 to complete the table and calculate the range or your y values for each of the values of your domain. Okay, so one thing that I see here is I don't have any x's. Okay, well, x's is your independent variable. It doesn't matter what you use as your x values. Okay, so if we're in class, I'd give you guys the options, but I'll just go ahead and put some random x values in here. It does not matter what you use. I would always just put them in numerical order, but that's, you don't have to either. So let's see here, let's do -3, -1, 0, and 2. And again, it does not matter. And sorry, those are a little off. Let's see if I can make my table bigger. Nope. Okay, so what we're going to do is we want to plug it in, try to find each value. So this first one, we have 2 times -3 plus 3. Okay, that gives us 2 times -3 is -6 plus 3 is -3. Okay, the next equation, 2 times -1 plus 3. 2 times -1 is -2 plus 3 is 1. And you guys can make yours a little nicer. It's a little wonky. That's okay though. All right, next one, 2 times 0 plus 3. 2 times 0 is 0 plus 3 is 3. And last but not least, 2 times 2 plus 3. 2 times 2 is 4 plus 3 is 7. Okay, so when you're filling out a table, you can pick out your x values. If they give them to you, you use those ones. But if not, you can pick out your x values because remember, those are your range. That's your x values. So that's your independent variable. So it doesn't matter which x values you use. Okay, that is up to your discretion. Okay, but your y values have to be those certain numbers because you plug those x values in. So you don't get to choose your y values because those are your dependent variables. Okay, we can see here that this is the same exact equation. They picked the traditional -1, 0, 1, 2. You'll see that very often as your x values, but I did want you guys to notice that it doesn't have to be those x values. Okay, you can choose any x values you would like because they're independent. And when you plug those in, you get 1, 3, 5, 7. And if you graph them, they show up on your table like this, or your graph like this. Okay, so the next one, it says a function is shown in a table which equation represents the function. Okay, so we're looking at this table and trying to figure out which equation. So what I want you guys to do first is graph or put them in a table. So there's two ways you can do this. If you go click it, add item, you can add a table. And when you put this table in, we have -2 and 11, -1, 6, 0, 1, and 1, -4. Okay, so it gives us this graph that looks like so. You can't see it very well. Okay, but we want to create the equation. Okay, and we can see all of these are in y equals mx plus b. So first of all, we want to find our b value. What's our y-intercept? Okay, so if I zoom in here, I can see my y-axis crosses at 1. Okay, or we could look at that table and remember I want where the x value is 0. Also, you guys, if you want to make it a solid line, you can hold those dots and then click lines and it'll connect it for you. So that can be super helpful. Okay, so I have a b value of 1. So if I look at all of my equations, there's actually only one of them that has a b value of 1. Okay, but we do want to double check that slope, which is -5. So let's go ahead and check that. If I start up here, remember I want my rise over my run. So start at the left point and go to the right point. We have a rise of 1, 2, 3, 4, 5. Remember, but we're going down, so that's a -5. So a rise of -5 and then over 1. So -5 over 1, that is -5. We can also see the same thing in our table. If we look at the 11 to 6, when I go from 11 to 6, remember that's subtracting 5, right? And then on the other side, we have -2 to -1, that's adding 1. So it'd be -5 over 1, which again is -5. So the equation is D. Okay, but remember Desmos, you can always graph them. So sometimes it can be very difficult to find everything in the table. Some people are more visual and like to use the graph. So remember, you can always graph them in Desmos. Okay, number 6 says which of the functions is which of the relations is a function? Okay, so remember we want only one x value to each y value. So we want to see which of them is repeating or which of them does not pass that vertical line test. Okay, so if we look here at all of our x values, nope, looks like they're all different x values and all to y values. If we look at the vertical line test, we can see that none of them have 2 points on a vertical line. Okay, we do see here the y values repeat. That's okay, okay, because remember the x values can only have one y value. Okay, so we still have -3 only has an output of 6. Okay, and I don't see a -3 in there anywhere else. Okay, so again, it's that x value only has that one y value, can't repeat. Then in graph 2, we can see here, let's look, do I have any x's repeated? Oh, here's 2 is repeated twice. And then if I look down here at 2, it does not pass that vertical line test. Okay, so it is not a function. So number 2 is only a relation. So graph 2 is a relation and graph 1 is a function. And it really should say function and relations because remember, every function is a relation. Okay, looking at the tables, which relation is a function? So again, guys, we're looking at those x values. Do they repeat? Okay, so if I look here at this first one, the x values don't repeat. That each x value has only one y value. Okay, so that one's good. That one is a function, but let's just check the other ones. Okay, b here has 2, so that is not a function. Okay, and then last but not least, this one is also a function. Okay, so it should actually be A and C because this one does not repeat itself. Okay, I will make sure that when you guys go through, you can actually click both of those, but it should be both of them because those x values do not repeat. Number 8, it says complete the table for the relation and fill in the values for your domain and range. Okay, so we have a list of points here. So I think the easiest thing to do first is to go ahead and type your x values into your domain. Remember, your domain is your x values. So 5, -1, 2, and 1. And your y values are 4, 3, and I have 2 3s. You don't have to type them twice, and 6. Okay, so you can go ahead and write all of those there and then do your mapping. So which values go to which one? So 5 goes to 4, -1 goes to 3, 2 goes to 3, and 1 goes to 6. Okay. And then we can do the same thing for the table. Table is slightly easier. We have 5, and if you would like to put them in order, you can, but you do not have to. -1, 2, and 1. And on the other side, we have 4, 3, 3, and 6. Okay, so here we can see our mapping and our table for that set of points. Hey, remember, those x values are domain and your y values are your range. Okay, then I asked you, is it a function? Okay, so remember, we want to know, is each x value have its own y value? Okay, or are any of those x values being repeated? Okay, so remember, we can have a repeated y value. So each of these x values only has one y value. Okay, so yes, it is a function. So go ahead, guys, and I want you to do 10, 11, 12, 13, and 14, and 15 on your own. Remember, you can rewind this video if you guys get stuck on any of those. We went through each of these together. So you guys can rewind if you guys get stuck. I will be giving you guys comments. If you have any questions, go ahead and throw it in that little message box and I will see it myself. Hey, your exit ticket, fill out your exit ticket for me. And then your homework today is 3.2 Intro to Function Rules Go Formative. And then lastly, there's a bunch of IXL help if you guys are struggling. Give those a try. Okay, remember, those are some more practice for you. Have a wonderful day, guys, and I'll see you tomorrow.